Hello everyone, welcome back to the channel. So in this video I am going to explain some of the PySpark related questions. So if you have a data engineering interview coming up, this will definitely gonna help you. So today we are going to walk through the most common must know PySpark interview questions and core concepts. Okay, and I promise to keep it super simple and easy to understand. So let's dive right in. So let's start with the first interview question. So these are the classic PySpark interview questions. Okay. So this is a narrow versus wide transformation. So what is a narrow transformation? So we'll take a couple of example here. So think of this like sorting your own laundry basket. So here you don't need help from anyone else, right? Your data stays exactly where it is because computers don't have to send data back and forth to each other. So that's why it is super fast. And filter is one of the narrow transformation functions we use in PySpark. On the other hand, wide transformation is a bit slow because think of this like organizing a giant library with your friends. So here each one of your friend has to swap books across the room, right? Data gets mixed and moved across the whole network, which we usually call a shuffle. So this takes a lot of time and memory. And group by key is one of the wide transformation we use in PySpark. Now take one more example. So imagine three chefs in a kitchen, okay, and each one has their own basket of mixed fruit. And suppose if the boss says throw away all the rotten fruits, so here what will they do? So here every chef can just look at their own basket and remove all the bad ones, the bad fruits out of it, right? So here they do not need to talk or pass fruit to each other, right? They are independent here. So that is a narrow transformation because data doesn't need to move across the network. So that's why it is incredibly fast. So as I mentioned, filter we have with column, that is one of the narrow transformation function we use. On the other hand, wide transformation. So now imagine the boss says, I want one basket with only apples and one basket with only oranges. So here the chefs can no longer work independently, right? They must stop, talk to each other, and pass fruits across the kitchen to combine all the apples into one spot and all the oranges in one spot, right? So this is called a shuffle, which we have mentioned before. And here Spark has to physically move massive amount of data across different machine in the clusters so related items end up together. That is why wide transformation are much slower and heavily consume memory. So the example of wide transformation are group by key or group by, order by, join. All those functions are known as the wide transformation function which we use in Python. Okay, I think it is clear now the difference between narrow versus wide transformation. Okay, now the second question is the difference between group by key versus reduce by key. Okay, so to understand the difference, think of a key value pair as a labeled folder. Imagine you have 1,000 folders, okay, and each folder is labeled with a city name. And inside each city name folder, we have a list of temperatures. Okay, so what this group by key will tell your workers, it will tell you like grab every single temperature folder from every single room, put them together and bring them to my desk, right? So what is the problem here? The problem here is city has so many temperatures that it overflows the desk, and this usually causes program to crash because it moves all the raw data across the network before doing any math, before doing any calculation on top of it, right? So that is the functionality of group by key. On the other hand, reduce by key is a smart summary approach. So it will tells your workers, don't bring me all the folders yet. First calculate the average temperature for each city in your own room, then just bring me the final average. So here you only get a tiny summary of data moving across the network. So that's why reduce by key is incredibly fast, efficient and rarely crashes because you are already shrunk the data before it started traveling, right? So in a simple term, group by keys is like send all data, then calculate. It is slow, high risk of crashes. Reduce by key is calculate locally, then send only the results. That's why it is fast and efficient. So just remember this golden rule. We always use reduce by key because it is much faster and prevents your system from crashing. Okay. So that's the basic difference between group by key and reduce by key. Okay, now let's cover the next question, which is a saving data technique, cache versus persist. So if you are using the same dataset multiple times, what usually we do, we usually save it so that we don't need to recalculate it, right? So here, if I talk about the cache, it's very simple. Cache is the easy button. You press it and Spark uses its default storage rules, which is saving your data straight into memory. So it's super fast to access. Okay, so that is cache for you. On the other hand, persist is the advanced button. So persist gives you manual control. Like if your data is too big for your memory, persist lets you tell Spark to save it to the disk instead. So instead of saving data on the RAM, we have the access or we have the capability in the persist to save the data in the disk if the volume of the data is very big. Or even we can save a backup copy on another machine as well. So usually use cache for everyday task and use persist when we need fine-tuned control. Okay, so that's the basic difference between cache and persist if somebody asks you. Okay, now let's talk about managing data chunks question, which is the difference between Coalesce and repartition. So this is the very important question which company usually asks in the PySpark data engineering interview. Okay, so what is Coalesce first? So Coalesce is simply a gentle merge approach. So what it does, it takes existing partitions and simply merges them together to create fewer partition. Okay, so here it avoids a full shuffle whenever possible because it doesn't move data across the network. It just combines data that is already sitting on the same machine. So it is much faster. And when we use it, when you want to decrease the number of partition, then we can use coalesce there. On the other hand, departition is like a redistribute approach. So how it works, it performs a full shuffle basically. So it spreads your data across the entire cluster to ensure every partition is perfectly balanced. So suppose we have three partitions, one partition is fully overflowed, the third partition is empty. So it will try to repartition the nodes in a way like it will redistribute the data in a way like every node will have equal amount of data. So that is shuffling there. So because it physically moves data to new location to rebalance everything, it is computationally expensive and slow. And when you need to increase the number of partition or if your data is highly skewed, data skewed means one partition has way more data than others, and you need to even it out basically. So in that case, we can use repartition. Okay. So just remember the golden rule. Use coalesce whenever you are just shrinking the number of partition. Only use partition if you absolutely need to move data around to fix a data balance issue or increase your partition count. Understood? So this is the basic difference between coalesce and repartition. Okay, now let's look at how PySpark handles data structures over time. Okay, so first we had RDDs. They are the low level foundation of Spark. They are great, but they don't have a schema like column names, and Spark can't automatically optimize them for you. Okay, then came data frames. These are what you will use 99% of the time in PySpark. They look like SQL tables with named columns, And the best part is they use something called the catalyst optimizer, which acts like a built-in brain to automatically make your code run faster. Okay, and then the data sets. These are highly structured and strictly typed, but here is the catch: they aren't natively supported in Python. They are mainly for Java and Scala users actually. So that's the three type of format we use it in Spark. DataFrame is something which is getting popular and everybody is using DataFrame in day-to-day PySpark work. Okay. Okay, now let's talk about the next topic, which is UDFs, which is a famous interview question like user defined functions. So first of all, what are they? So sometimes built-in functions are not enough and you have to write your own custom Python logic. So those we call as those functions we usually call as user defined functions, right? But but what is the problem in this Spark? The standard PySpark UDFs have a massive bottleneck because Spark runs on Java and your custom code is in Python. The data has to be translated and serialized row by row between the two. That is why it is very slow. Okay. So in order to fix it, the Pandas UDFs has been introduced. It has been introduced in Spark 2.3. They use a technology called Apache Arrow. So instead of translating row by row, it transferred whole block of data at once with zero copy overhead. Okay. So that's why it gives you massive speed up. So that's the importance of PySpark UDF functions. Okay. Okay, now let's talk about the custom accumulators. What are the custom accumulators in Spark? Okay. So think of accumulators as a global shared counter that lives on the driver, which is the main program, but can be updated by all the executors, which are the worker machines in your cluster, right? So first of all, why do we need them? So in Spark, standard variable don't work across multiple machine. So if you create a normal Python variable like my underscore counter equal to 0 and increment it inside a Spark task, each worker will just create its own local copy. So when the job finishes, the main program will still see 0. So accumulators solve this by safely reporting updates back to the driver, right? So let's give me a simple example here. So imagine you are processing a massive log file of 1 billionth line and you want to count how many lines contain the word error while you process the data. So for that, we'll first create the accumulator. We'll initialize like suppose error underscore counter equal to sc.accumulator 0 on the driver. Use it in your code as your workers process the data. Whenever they find a line with error, they call error counter dot add one. We'll add a one in error counter. That is the accumulator we have initialized, right? And the result will be Spark automatically handles the complexity of gathering those adds from all the different machines and sums them up into one final total on your driver. So it will check all those error message in all the slave machine, all in the worker machines. It will sum all the counters value wherever the error is matching, and then after calculation it will sum up it and bring back the total count to the main driver machine, right? So that's the custom accumulator here. And the golden rule is only update accumulators inside Spark actions like we have .count, .collect or .save. And why it is so? So if we use them inside a transformation like .map, Spark might rerun a specific task if a machine fails. So if that happens, the accumulators might get added twice, giving you an incorrect total because actions are only executed once. They are the safe place to use them. So that's why we use the accumulator inside Spark actions, not with Spark transformation. Okay, so that's the custom accumulator for you. Okay everyone, I think you have got this now. So these are some of the PySpark interview questions which company usually ask. And in the next video, I will be covering more questions related to PySpark and data engineering, which nowadays the top tech companies are asking the candidate. So it will be helpful for you to understand the type of question companies are asking. Okay. So till then, thank you for watching my videos. Take care. Bye bye.